In this first question about exponent rules, I want to just get a few rules in front of you so that you could remember those. So the product rule is the first one that we're reviewing here, and the product rule says that if you're going to multiply like bases and you add their exponents. So in this problem, what I wanted you to be able to think through is that when you multiply like bases, you add the exponents, so it's going to be m to the a plus b. This one is called our product rule. In the second one, we have a rule that states anytime you have a power raised to a power, as we have here, m to the a raised to the b, that's equal to m to the a times b, and that one's called our power rule. A third rule that we have is when we have like bases, like m to the a divided by m to the b, we can subtract their exponents. So m to the a divided by m to the b is equal to m to the a minus b, and that was called our quotient rule. Okay, so those are the three big ones on monomials. If you notice, each of these, A, B, C, these are all rules on monomials. So we want to apply these only to monomials and not go into binomials with them. And there are other few rules here that we know that anything raised to the power of 1 is itself. Anything raised to the power of 0 with the exception of 0 is 1. And this one, the one that keeps getting us a little bit, is anything raised to the negative exponent is the reciprocal. So right now, I have m to the negative 1, and this is m to m over 1 raised to negative 1. So this negative exponent means I can reciprocate this 1 over m to the first power, which is just 1 over m. So our rule is to reciprocate whatever the base is and make it 1 over, just trying to get a better color here, 1 over m. Okay, so I want to just go into a little bit more detail on that one. If I have m over n to the negative 1, that means I'm going to reciprocate that and just make it n over m to the 1, which is just m, or n over m. Now if we have m over n to raise to the negative 2, negative 3, or anything else, this negative says reciprocate that base, so it's going to be n over m raised to the second, and now we'll use our power rule. Since these both have exponents of 1, it'll be n squared over m squared. And there's one more situation that keeps popping up that we have a little bit of difficulty with, and that is if I have m to the negative 2 times n over n to the negative 3, how we can rewrite this. Well, this one says I only have m raised to the negative 2, which means I have to reciprocate this base. To reciprocate the base would be 1 over m, or we'd push it to the bottom. So in essence, this m to the negative 2, if it's only on our single term here, then it's going to be m squared at the bottom. This n to the negative 3 says I need to reciprocate it. If I reciprocate it, this n over 1 becomes 1 over n to the third, and that gets moved up to the top, which means it's going to be n to the third times n. And now we can use our product rule and say it's n to the fourth over m squared. So just a few quick pointers there on monomial rules on exponents.